Okay, today we're going to be talking about differences of squares. So that will look something like some a squared term minus a b squared term. And that can have variables in it, constants, that kind of stuff. The idea is that we're going to miss that middle term of FOIL. So that middle term, which would normally have a and b multiplied together, will now be eliminated completely and we'll have 0 ab. Again, like if I factored what I have above, I would have a plus b and a minus b. So kind of keep this part in mind when I see, that was supposed to be a highlighter. When I see something like this, I can jump straight to here, okay? Because sometimes it doesn't have that middle term and I still need to be able to factor it, and so that's when the difference of squares rules comes in. And this doesn't mean a whole lot if I don't give you some kind of example. So let's look at 16h squared minus 9a squared. Well, I can see that h squared and a squared are perfect squares, but also look at 16 and 9. Those are both perfect squares as well. And if I take the square root of like 16h squared, I mean, first of all, I'll have my 16 and my h squared. This goes into h and h. This breaks down into 4 and 4. So that's 16h squared is my a squared term. My a term would just be, you know, part of that, the 4h, the thing that's repeated. Same thing if I do my 9a squared. I can break that down into 9 and a squared. 9 breaks down into 3 and 3. A squared breaks down into a and a. I take one of each pair, so I have a pair of 3's. I take one of those. I have a pair of a's, and I bring down one a. So my b term is that 3a. So now I can go ahead and plug that in to here. So I should have 4h plus 3a, 4h minus 3a. Okay. And I could do this all without the difference of square rules. It's just going to take me a lot longer because I'm going to rewrite it with that that 0ab term in the middle, and then do my factor sum tables. And if you have something like this, where it's 16h squared and 9a squared, I'm not really wanting to multiply 16 and 9 together and then trying to find the factors of whatever that is that sum to something else. So this is just an easy step kind of to break it down. And if 16h squared is a big number, 9a squared is larger. If you don't want to do this all the time, we don't have to. So I'll show you on my next one. I have x squared minus 9. This is a lot easier. I know that I can break that x squared into x and x. One of them is plus, one of them is minus. Square root of 9 is 3. So my answer would be x plus 3, x minus 3. Okay, so try this next one on your own. X squared minus 4. How would I break that down into the two factors? That's exactly right. I would break it down into x plus 2, x minus 2. And this example that you just did will be really helpful in our next one as we get a little bit bigger. So my next one, I have b to the 4th minus 16. Well, I can break b to the 4th down into b squared and b squared. I have 1 plus, 1 minus. And I do write them plus and minus, positive and then negative in that order for a reason, and you'll see that here in this example. 16 breaks down into 4 and 4. I can't factor b squared plus 4 anymore. That plus means it's a sum of squares. I can't do anything with it. Remember, we're talking about differences of squares. But this difference of square, b squared minus 4, is something I've seen before here. I can break that down even further to b plus 2, b minus 2. And of course, I bring down that first factor, b squared plus 4. So to get it completely factored from b to the 4th minus 16, I have to break it down like this. So this b squared to the 4th breaks down a little bit even more. Okay, so that's what, if it says on a test or a quiz, factor completely, make sure that you don't have any more, when you factor it that first time, like here, make sure you don't have any more factors of squares that could go down like that. So we do want to factor completely. And of course, we can kind of, let me give you an example for that one. Of course, we can also factor by grouping and then do some factoring with some, differences of squares. So for instance, I have 5x to the 5th minus 45x. Neither one of those are perfect squares. 5, if it's an odd exponent, you really can't do that. But I see that I have an x in both, and I have a 5 in both. So I'm going to pull that 5x out so that I have x to the 4th minus 9. Then this breaks down. So I would leave that 5x on the front. X to the 4th would break down into x squared and x squared. 1 plus, 1 minus. 9 breaks down into 3 and 3. Can this x squared minus 3 break down even more? No, because 3 is not a perfect square. I can't take the square root of 3 and get an even number. So my final answer would just be this. So why don't you try an example like that as well?